Waiting times for patients at a hospital or emergency department can be up to 4 hours. The associated probability density function is shown below. What is the probability a patient will wait less than 1 hour? So that is going to be the area of the triangle shown here. Now the base of the triangle we can readily see is 1. But the height we can't really read from here. But what we do know is that this is at a half. So it makes sense that 1/3 of that distance, because remember this is going 1, 2, 3 units across to 1.5 here. So just using similar triangles, this is going to be 2/3 of a half, because the top here is at a half. So that is going to be at 1/3. So the height of that triangle is 1/3. So the probability that the time is less than 1 is going to be the area of the triangle, which is a half times the base times the height, and that's going to be 1/6. There are other ways you could have done that. For example, you could have worked out the equation of this line. So rise over run, we can see that it's 0.5 over 1.5, and then you could have integrated that function. Now the second part of the question says, what's the probability a patient will wait between 1 hour and 3 hours? So it's going to be this area here. And frankly, I'm going to do this by working out the functions and integrating rather than doing lots of horrible work with fractions. So in the first part of the question, I already spoke about the fact that this line is y is equal to 1/3 x. So what about this one here? Well, the gradient there is, so the y goes down by a half, while the x goes across by 2.5, which is 5/2. So that gives me a gradient of -1/5. So y is going to be -1/5 x plus some constant. And we know it goes through for 0. So 0 is going to be -4/5 plus c, so the c is equal to 4/5, giving us that that one is -1/5 x plus 4/5. So if we're after the probability, remember we're after an area, then what I'm going to do is integrate this bit. So I'm going to do the integral from 1 to 1.5 of 1/3 x dx. And then I'm going to integrate from 1.5 to 3, -1/5 x plus 4/5. Still going to be doing some horrible work with fractions, I think. So this one is going to be x squared over 6 from 1 to 1.5, and this one is going to be -x squared on 10 plus 4/5 x from 1.5 to 3. So 1.5, remember, is 3/2. So if we square that, that is 9/4, then divided by 6, so that's 9/24. Take away 1/6, which of course is 4/24. And then we're adding. So when we get 3 over here. That is going to give me negative 9 over 10 plus 12 over 5, which is 24 over 10. And with the 1.5, that's going to be, so 1.5 is 3 over 2, square that is 9 on 4, so that's going to be negative 9 on 40 plus, then we've got 4/5 times 3 over 2, which is 6 over 5. Okay, so this one's 5 over 24. What do we have over here? We've got 24 take away 9 is 15. So that one is 15 on 10. And then over here, this bit would be negative 9 on 40 plus times top and bottom here by 8, it'll be 48 on 40, which is going to be 39 on 40. Okay, so let's just clear a bit of space over here to continue our work. That is going to be 5 over 24. Now this one is 60 over 40, so that's altogether going to be 21 on 40. Common denominator for those will be 120. So multiply 24 by 5 to get there, so that one's going to be 25. Multiply 40 by 3, so that's going to be 63. So that is going to end up being 88 over 120, which is 44 on 60, which is 22 over 30, which is 11 over 15.